Here we have a cube, and here I have the net of the cube, and this net of this cube has 6 faces, 1, 2, 3, 4, 5, 6, and when you fold it up, it makes a cube. It just folds up into a cube. Now this is the edge of the cube, and these are the corners of the cube. Next we have here a cuboid, and this cuboid, this is the net of the cuboid, and here is the solid that is formed. So it's a rectangular prism. We fold up and we get a rectangular box, right? So again, here is the net. In this example, this 2 sides here is a square, but it doesn't have to be a square. It can also be a rectangle. It can be longer and it can be shorter. Again, the cuboid has 6 faces, but unlike a cube, it is not all square. Here I have with me a cylinder, and the net of a cylinder is actually a rectangle. So the rectangle has a length and width. If I fold the rectangle, roll it up to make it into something round and like a cylinder, like this, you will see that this length here, that is the length of the rectangle, becomes the circumference of this circle that is formed at the end here. And then the width of the rectangle becomes the length of this cylinder that is being formed. That the cylinder has 2 circles, one on each side, and the circles are of the same size. Here is a triangular prism. A triangular prism has 2 triangles at each side. Here 1 triangle, and the other side is also a triangle, and the other faces are all either rectangles or square. So this is the net here. There are 3 these rectangles, 1, 2, 3, and then there are 2 triangles, 1, 2. Right, the 2 triangles are equal. They're the same triangle, but they do not need to be equilateral triangles, but they have to be the same size. So when I fold this up like this, it forms like a tent. Yeah, it becomes like this, and then the 2 triangles close up the solid to form a solid. So again, here, this is the triangular prism. Here we look at a pentagonal prism. A pentagonal prism has 2 pentagons. Pentagon is 5-sided figure, so we count 1, 2, 3, 4, 5. This is one side of the prism, and the other side we have the exact same pentagon, 1, 2, 3, 4, 5-sided figure, and we have either rectangles or squares surrounding it. And here is the net of the pentagonal prism, 1, 2, 3, 4, 5. There are 5 rectangles and 2 pentagons, so that I can fold them up to form this shape, right? So that's quite it. Here is a hexagonal prism, and again this hexagonal prism is, and the hexagon is a 6-sided figure. 1, 2, 3, 4, 5, 6. There are 6 sides. Just like the pentagon has 5 sides, the hexagon has 6. So the hexagonal prism has 2 hexagons, one on this side and the other one on here, exactly the same dimension, the same hexagon, and in between you have either squares or rectangles. surrounding it. So here is the net for it, right? You have this one hexagon here with attached 6, in this case example is 6 squares, but it doesn't need to be 6 squares, it can be rectangles. Then you just fold it up, and then it covers up, right? The top hexagon goes on top. So there are 2 to get this shape where there are 2 of these and 6 either squares or rectangles. We next look at a shape that is quite important actually. It's called a tetrahedron, and it is actually made up of 4 triangles. This is the shape itself, the solid shape. You can see that it's like a pyramid, and it has a triangular base. It only has triangles. There is nothing, no other shape except the triangle. So if you look at the net for this, it's 4 equilateral triangles. 1, 2, 3, 4. And when we fold this up, it forms a tetrahedron, right? It's a triangular pyramid, a pyramid with a triangular base. The base of the pyramid is triangular, and this can be a vertex, and this vertex is in the middle of this base. If you drop a perpendicular line inside this triangular pyramid, right inside, and a straight line, it will hit the floor of this pyramid right in the center of it, and that is the vertical height of this triangular pyramid. It's called a tetrahedron. It's made up of 4 equilateral triangles. Another basic shape we want to look at, it's the pyramid with a square base, right? So here is the pyramid with the square base, you can see that, and with it are triangles all round. So this is the net for it, with the square in the middle, and then with the triangles connected to each of these sides. If you fold this up this way, it will form that pyramid, and all the triangles here, you can see they are the same. They are the same in area and in dimensions. The measurements are the same. They are actually isosceles triangles. So these 2 sides are equal, these 2 lengths are equal, but this one here is different. They don't have to be isosceles triangles, they can be equilateral triangles, but in this example they are isosceles triangles. So you fold them up, and the vertex here is in the middle, meaning if I drop this a line or a vertical height from inside this pyramid all the way to the floor of the pyramid, which is a square, it should be in the middle of the square, that vertical height. So that is the vertical height of a pyramid, the vertical height that is inside the pyramid. Then the pyramid actually has another height. This is the slanting height of the pyramid, right? And this is one edge of the triangle. This pyramid has 5 faces. 4 of the faces are isosceles triangles, and the base is also a face, and it's a square, so it's a square pyramid. If you have a pyramid with the vertex not in the center, it means that the triangles are not equal. They're not the same. Here is a pentagonal pyramid. A pentagonal pyramid has a pentagon base, a base with which is a 5-sided figure. 1, 2, 3, 4, 5. So this is a 5-sided figure, and on each of its edge is a triangle. And in this example, it's an equilateral. It's an isosceles triangle, right? With these 2 sides equal, and that is this one last side is separate, it's not the same. So it's an isosceles triangle, and there are 5 of them. So the net of this figure is here, and again you see this one base here, it's pentagon. So, and when I fold it, it folds into this shape here. Again, the vertex is in the center. If I drop a line from the inside of this pyramid down to the base, it will touch the floor at 90 degrees in the middle of the pentagon base. We have here a hexagonal pyramid, and a hexagonal pyramid has a hexagon base. So the base of the pyramid has 6 sides. A hexagon is a 6-sided figure. So if you count the number of sides, the number of points here for this hexagon, there are 6 of them, right? 1, 2, 3, 4, 5, 6. So the 6 sides of this is a 6-sided figure, and each of these sides has a triangle, and in this example it is a isosceles triangle, right? And there are 6 of them. So this is the net. When we put this together, we will see that when we fold this together, we will see that they actually form a pyramid. This pyramid actually has a vertex in the middle. If I drop a perpendicular line from the middle of this pyramid, it should go down to the floor of the pyramid and touch the center of the hexagon. Now we have a cone, and a cone is a pyramid with a round base. So the base of this cone is round, and like other pyramids, it has this vertex, the sharp pointy edge at the top. And if we drop a perpendicular from inside this cone all the way down to the floor of this cone, the base of it, you will see that that vertical height, that vertical line will cut the center of the circle. Here is the net of this this cone. It used to be a big circle, and then we cut out the circle, right, to form this shape. Then this is part of the circumference of a big circle. We fold it like this, right, so that it becomes a cone. And this one you see here, this flap you see here, it's just the base circle that you like folded, and these things you see out here are just things for you that you can put either tape or glue to glue the circle in place, and to hold the cone in place. So I made this. You notice that when this was a big circle, if you look at this shape, this was once a big circle. This whole section here was once a big circle, and from here to here is the radius of that big circle. When I formed the cone, I noticed that you see that radius becomes the slanting height of the cone, right? So this was once the radius of a circle. When I fold it up, it becomes a cone, and then the slanting height of this from here to here, the slanting height itself, not the vertical height, the slanting height of the cone was the radius of the circle that has been cut to make the cone. And this part of the circumference here becomes this is part of the circumference of a big circle, and this part of the circumference here becomes the circumference of the base. You see, I do it this way, and when I put it together, this bottom part here is actually made up of this whole length. So this cone again has a vertical height, and inside. The vertical height is inside the cone, in the middle of the cone. You drop a line from the middle of the cone to the floor of the cone, and that should touch the center of the small circle, the base that is of the cone, right? But the slanting height of this cone here is actually the radius of the circle that was used, the big circle that was cut out to make the cone. Here we have an octahedron. An octahedron is made up of 8 triangles. So we have 1, 2, 3, 4, 5, 6, 7, 8 triangles, and they're all the same triangles, right? So it folds up into this diamond shape solid. There are no squares here, only triangles, and there are 8 of them. And this is the net of it, the equilateral triangles. So 8 of them, and when we fold them up, you will see that it actually does form the diamond shape, right? You just glue it together, and again you can actually cut this out, and then you can try it for yourself. So this is the octahedron, 8 triangles. Here I have the icosahedron with 20 triangles, and here is the solid that is formed. It has 20 triangles, and this is the net. If you try to connect and cut out this net, and then you fold it along these lines, you will see that the middle set of triangles, okay, actually close up to form a shape, and then those on top, those triangles that were on the top row will come together to close to form the shape, and the other set at the bottom will also likewise come together, and they close the solid to form a solid like this. So this is the 20 triangles of the icosahedron. Here is the dodecahedron with 12 pentagons. So 6 here and 6 here, right? You can count 1, 2, 3, 4, 5, 6 each, and 12. So this comes together to form this solid with 12 pentagons. It looks almost like a soccer ball, but it's not. It's not yet a soccer ball. It can be transformed into a soccer ball if you combine this with hexagons. But this is a dodecahedron. It's an interesting shape. It's not very complicated. You just fold this one set of 6 this way, and the other set of 6 will cover the top, and they will fit together to form this shape.